So, like she said, I'm Nick Santos. I'm here from the Center for Watershed Sciences at UC Davis, and my former boss now, Josh Veers, is the mastermind of most of the work I'm going to share with you today. And he is now the director of Citrus at UC Merced, which is how this interconnect happens. And so thinking about our work, as an academic, we have two missions. We have a mission of research and investigation, but we also have a mission of education and dissemination of that information to the public, to students, to whoever. And I'd imagine that the journalists in the crowd feel very similarly about their work. At the same time, as a water research group, we don't have a mission of technology development. And so while Steve's talking about this hardware they developed, our hardware needs to be stuff we could just buy readily. It needs to be something we can just go purchase, and it does most of what we want it to do. Maybe we'll hack a few things together. I'm a software developer, so I tend to make systems merge for us, but it mostly just needs to work. So I want to share with you some of the things that we're doing that are built on that technology, that mostly you can just go put some of the stuff together today if you have somebody with some technological expertise. And I'm going to focus more on demos. I may not describe to you exactly what we did or how, but show you where we ended up. And feel free to come talk to me afterward if you want to know a little more about why or how. So just for perspective, I hope you could see this map. It's a little cluttered. We're over here-ish, and I'm going to talk to you mostly about some work that's done here. We're working all over Sierra Nevada. We're working all over the state. But the work that we're doing has instances of it all in the Tuolumne River watershed, right where the Tuolumne River and the Clavey River meet. And with that, I'm going to switch to, hopefully, one of these demos. And so it begins with a simple photograph. We've all seen photographs. They help us understand a place by viewing it. And it's a point in time. This one happens to be from, I want to say it's May, June 2013. It's lush, it's spring, there's water coming down the river. But if you've ever seen a gigapan before, this isn't an ordinary photograph. It's a very dense photograph. So if I start going in here, we can pretty quickly make out a person. And if that finishes loading, she'll get a little clearer. And this encourages you to explore, right? You want to say, well, what else is around here? What did I miss? Because if I zoom out, she doesn't exist anymore. From here, we see the big picture, but when you zoom in, you get to go see what else is there. And so we're exploring from one perspective, but it still says, come find what else is here. And for education, this is really great. We're very interested in this gravel bar. So from this perspective, we want to see what's on this gravel bar. And we can see cobble size. We can understand what kinds of rocks are there, the water level, using that little plant as a point of reference. I can do this for days. So, but if you, I made the classic mistake of not putting up our URL or our website on my presentation. So it's watershed.ucdavis.edu. Before I forget, you'll be able to find all this there if you want to go do this yourself. And so this is one way of doing it. This is one perspective of one spot. If we move further up the watershed, what we're experimenting with now is these virtual field trips that encompass a lecture that would typically take place in a classroom for students. But instead, this is another gigapan here. This one's amazing. This one's partial resolution. But if we move to this site, we can explore in 360 this whole location. And we have 50 sites mapped here throughout this watershed that you can go explore. And if you want to take a linear approach to it, there's a lecture down the side. And I can click here, and it's going to take me to a video where Sarah Yarnell explains to me habitat processes for this area. So I can follow this down and be linear. Or, again, I can just explore. I can zoom in on all these 360-degree spheres and explore a spot. I can move to the next location if I can find it. I can move to the next location, and there's a connectedness of this space. And so for education, this is really wonderful. And I think that it's going to be the direction that a lot of magazine-style reporting on places is going to go. If any of you have seen National Geographic online or the New York Times Magazine, they're doing an amazing job of integrating multimedia into their reporting. And this is a natural extension of this. It may be clunky, but it's still very new. So that's all I'm really going to say about this on the education side. But now, what about how do we take data that we can analyze, that we can come up with results from, that really helps us understand a space, not just subjectively, but more objectively? And I think that's where I go to here. And part of that is, how do we understand place over time? And our study site on the Tuolumne River at the Clavey Confluence just so happened to be in the middle of the rim fire last year. We had enough instrumentation out there to get a lot of data during the rim fire, and it happened to be a spot that was low enough intensity that our equipment didn't get destroyed. So we felt like we got pretty lucky, and you could tell that it's a researcher talking about it when a fire sweeps through an area that's important to you. You're like, oh yeah, I got really lucky. I get to investigate this. So because we could, we took that original image here and put it on one side. This is from May, June. And then we took the image that we could get from that same location and put it over here. And that's right after the rim fire. And this helps us just visually explore change in an area. We align these images and just put them together using some code that is readily available online. I didn't do too much hacking together of this. Pretty much any software developer could have done this. And you could play with this all day. You could watch trees disappear. If you watch that tree over on the right there, it's green here, and then it just disappears. It's dead. But mostly what this told us about the rim fire is that this was a very low-intensity burn location. This burned much more like Sierra Nevada historically. Mostly the trees survived and the grasses are dead. And again, this is another thing I could do all day. I could just slide back and forth and watch that ridge line. The coworker who did the alignment of these images did a fantastic job. But again, we could watch that bar and see what happened around it. So this is one other avenue to begin exploring these locations. The next is, where's my presentation? The next is we have, before I go on, that was all made with a Nikon camera with a stock zoom lens, and a Gigapan mount. And then we took it and brought it into standard GIS and aligned these images together. Nothing too fantastic about anything we did there. So this is all stuff you can do. And then next, were any of you here for a research exchange a couple weeks ago where Josh Veers spoke? Wonderful. Then this will be new to all of you. So on the right here is a very similar shot to what you've been seeing today. That's the Tuolumne River at the confluence with the Clavey River going upstream. And this is a camera maybe half a mile upstream on the Clavey River. And we took game cameras, camera traps. They take a photo every hour at these locations, and they're deployed all year. Day and night, they're taking photos. And we also have loggers in these rivers. And what we want to understand at this location is, how do our water management strategies affect the ecosystems? And what this particular site tells us, like a number of other sites where we're doing the same thing in the Sierra, is there's a dam upstream of the Tuolumne River here. That's the O'Shaughnessy Dam at Hetch Hetchy, provides San Francisco with a lot of its water. And there's no dam on the Clavey River. And it's a direct tributary. These sites are pretty much in the same spot. They're experiencing the same events, but there's a key variable differing between them. And but with that bar, what we want to know about that bar is, what kind of habitat is that providing for amphibians? How can they be raised? And the rate of water change on a bar matters for amphibian reproduction. It's really hard to understand that from just stream flow. We may know how much water is in the river, but we don't know how it's changing on that bar. So with these cameras and with the data, we can put together something much more rich. So I'm going to hit play and hope it works. Great. So a ton of data moving along here. And you'll notice 3 lines on these graphs. And the blue is stage or flow for each river, and they're overlaid on top of each other. The orange is water temperature, and the green is air temperature. And the images are matched up. Same moment is being shown for each image, and the graphs are showing the moment in time that the image is showing. And first, I think it's just amazing to be able to watch a river. But we can see events like that. And notice that it appeared in the data on the left where we have a logger. But on the right, where we're taking data from a USGS gauge that's a little ways upstream, that water, or that high flow event didn't show up. So maybe there was a localized freshet or something like that occurring. But what's really interesting about this that we can see comes a little later. And I'm debating whether or not to let it play. Since it's a lightning talk, I'm just going to skip forward. You get to miss part of the picture. But we start to approach this peak. And so far, they're both running higher as we get further on into the season. But once we cross the peak coming up, they're going to diverge dramatically. And the Tuolumne is going to just change erratically based upon the dam, mostly for river rafting needs. And the Clavey River is going to have this nice, smooth spring snow melt recession. And what that is snow pack slowly disappearing and tailing on off to summer base flow. And this is what our ecosystems are adapted to. And so it's nice to see that it exists in spots. But then on the Tuolumne River, it's just going to go up and down, up and down, up and down. And that's called hydropeaking, and the water releases daily. And so we can watch them differ, but then we could also watch how that bar comes in and out of the water once that happens. It should be pretty soon. The other thing to note here is the air temperature and the water temperature on the Clavey River are coupled. They're mostly tracking each other. But once we get to the hydropeaking period coming up in particular, the Tuolumne's air temperature and water temperature are going to diverge. They're no longer coupled. And that's because the Tuolumne River, it's a bottom release dam, and the water coming out is colder. And that alters the ecosystem itself. And a lot of these things are things you might say, well, sure, we knew that from the data already. But when you get to watch it and see what changes downstream from that, and also see, well, what's happening right next to that when it's not affected by that, you can learn a lot more from that. It's a powerful visualization tool, one that we've sent to SFPUC, and they've enjoyed too. So we hope to make a lot more of these videos. And then, if I still have just a little more time, perfect. The last thing we're doing is we're doing a little bit of drone work, which will be a nice introduction to Yongchuan Chen's work coming up. And we can do more event-based monitoring. We can go out before something happens, and then we can go out immediately after something happens. And because drones allow us to monitor places in much higher resolution and much more rapidly than we could before, we can get data before and after an event and understand what changed over time. We used to be able to do that, but it was a lot more time investment of individuals and also a much higher investment of of equipment. And so for $5,000, we can have a setup that lets us get a basic sense of a place. We can go out for a couple hours and gather data, and then we can go out maybe after a massive flood moves everything around and gather information again. And we can get orthophotos, corrected aerial imagery for an area, and it's at incredibly high resolution. There's that gravel bar again. And so this is the whole landscape, and there's that bar, and this is it once we zoom in. So I think that's all I have. I just wanted to share that all these cheap sensors are changing the way we're able to do our research and the way we're able to communicate to the public. So thank you.